All right, let's jump right in. Today we're tackling a question that's, well, it's one of the biggest in all of science. We have these amazing theories that can predict how the universe works with mind-blowing accuracy. But what if despite all that success, we're fundamentally misunderstanding the very nature of reality itself? Let's get into it.
And this right here is the absolute heart of the mystery. You see, physics has gotten so incredibly good at answering how. How does an apple fall from a tree? We got that. How does light bend around a star? We have the equations. How do tiny particles interact? Check. But the argument we're exploring today is that we've completely stalled on the why. Why is the universe even built this way to begin with?
So this is the key distinction you need to grasp. On one side, you've got what we call descriptive theories. Think of these like a perfect recipe from a master chef. It tells you exactly what to do, you follow the steps, and you get a perfect result every single time. It just works. But on the other side, we have what our source calls machinery explanations. Now, this isn't just the recipe, it's understanding the chemistry, why those ingredients react the way they do to become a cake. And in fundamental physics, that why page is still mostly blank.
So where do we even start looking for clues in this mystery? Well, our investigation begins in a place you'd probably never expect. Not in some giant particle collider, but in the very language we use to describe the universe, mathematics itself. And it turns out there might be some serious cracks in our foundation.
Just stop and think about this for a second. The concept of a number, 1, 2, 3, the most basic, fundamental building block of all math and physics. It doesn't actually have a complete, totally rigorous definition. We use them all the time, they obviously work, but we can't perfectly define what they are.
And it doesn't stop there. Take the concept of infinity. This idea is absolutely essential for modern physics, from calculus to cosmology. We couldn't do it without infinity. But it's the same problem. It's this powerful tool that we use constantly, but we've never really grasped or fully defined its fundamental nature. And all this brings us to continuity. The simple idea of a smooth, unbroken line. It feels so intuitive, right? A continuous flow. But mathematically, it's another one of these concepts we haven't quite nailed down. And this little loose thread leads to a pretty major contradiction. And this quote just nails the problem perfectly. We think of the number line as being continuous, seamless, but it's not. It's actually made of discrete, individual points. It's not the same as a truly smooth, intuitive line. We teach that they're the same, but they're fundamentally not. And this isn't some minor technical issue. It's a paradox at the very heart of how we describe space and time using math.
Okay, so if the very math we're using to describe reality has these deep, unresolved issues, what does that mean for our best, most successful theory of reality, quantum mechanics? Well, this is where the investigation takes a really radical turn.
Quantum mechanics tells us that, at its core, reality is uncertain, fuzzy, and based on probabilities. But the idea we're digging into today asks a really provocative question. Is the universe really like that? Or is all that quantum weirdness something that we create simply by the act of trying to observe it?
The proposed logic goes something like this. First, we decide to measure something. The moment we do that, we create a distinction, right? There's the thing being measured, and there's our measuring device. The argument is that this artificial division actually forces nature to behave in that probabilistic quantum way. We then see this result and mistakenly conclude that reality itself must be quantum, when in fact our measurement may have been what made it look that way.
So if reality isn't just a collection of fuzzy quantum probabilities, then what is it? Well, this leads us to the alternative theory at the heart of this whole explainer, a completely different way of picturing the cosmos. The idea is profound in its simplicity. What if reality isn't made of countless tiny, separate little parts? What if it's all just one single, continuous, undivided fabric? And what if all the particles and all the forces we see are just ripples and vibrations in this one unified substance?
Now, this represents a huge paradigm shift. For decades, the goal has been to quantize gravity, to basically force our theory of geometry, general relativity, to fit into the quantum world. This new approach flips that completely. It suggests we geometrize quantum fields. In other words, let's try to see if quantum effects actually emerge from a more fundamental, single, geometric reality.
So we have a new suspect and a potential new theory. But where do we find the evidence for something like this? Where do we even look to test this idea of a unified fabric of reality? Well, the thinking points us to a very specific place.
See, the answer isn't in looking at the biggest things, like galaxies, or the simplest things. The argument is that the key, the Rosetta Stone for understanding this whole geometric fabric, lies in deciphering the most complex and elusive behavior that we've ever encountered in the entire universe.
And that behavior belongs to the fermion. Fermions are the particles, like electrons and quarks, that make up all the solid matter you see around you. And according to this perspective, their behavior is the most mysterious and fundamental thing we know of. If we can develop a true machinery explanation for why a fermion behaves the way it does from this new geometric perspective, we might just unlock the true nature of reality.
And that leaves us with a final, profound thought. For centuries, our science has been about breaking things down into smaller and smaller pieces to understand them. But what if the ultimate truth isn't found in the pieces, but in understanding the undivided whole? What new universe might we discover then?